Hey everybody, this is Larry. This is day 18 of the February Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Double checking that this time I'm recording the screen. Okay, we're good here. So I am actually today in Cartagena. Hopefully I'm saying that correctly. So I'm doing a bed stream, so hopefully that's okay because even though I requested a room with a table, unfortunately, sometimes things just don't work out. And the internet's a little bit shaky, so we'll see what happens. But at least this should not require that much internet issues. So yeah. Anyway, hope everyone's doing all right. Hope everyone's having a great week so far. This is Friday, or wherever you want to watch it. Today's problem is 402. Remove k digits. Okay, so given string num represent a non-negative number. Suppose probably removing k digits from num. Okay. So these numbers usually, or these type of problems, I don't know if it's a type, but the way that I would always think about it is greedy, right? And why is it greedy? Because if you have two numbers, let's say or 1, 3, 2, 4, something like that, right? Almost it doesn't. I mean, so like the most significant digit, and they call most significant for a reason. Like that's all that matters, right? And only when it's tied early on that later digits matter. So in that way, we're trying to figure out how to and then we could figure out the rule in some way to figure out that how to be greedy in a consistent way. And many of the times there are some like what you might call it, like edge cases maybe to kind of think about different things. But for this one, probably it's not as hopefully it's not as tricky. So let's see. And the first thing I would do is just look at the examples and just kind of play around with like thinking about it, and because these kind of greedy problems with the most significant digits type thing, a lot of the time is intuitive unless you miss a case or something like that. But it's still mostly intuitive because you see the answer, you're like, oh yeah, of course that's right. So there's no like hidden cases almost, but it's just about like experience and your limitation of imagination, or just like practicing or whatever. So yeah, so the way that I look at it is look at this number. What are we supposed to do? The smallest. Okay, the smallest. So there's also maybe another way of doing it. Like okay, maybe not 10 to the fifth. Another way of doing it. So one is doing what they tell you, which is remove k digits. So in this case, you remove the 4, 3, and 2, as they say. The opposite, of course, is to keep x digits, right? Where x is equal to n minus k. So, for example, in this case, there's 7 digits. You have remove k is equal to 3. Another way of saying is you could keep 4 digits to keep it the smallest, right? And maybe that's the way to do it. Do I try to think, right? Yeah, and I'm just trying to think about which way is a little bit better. Uh, Also, this one, there is some strangeness to this one though, right? Because looking at example 2, even you remove 1 digit, you already lose a lot, which is really an awkward, weird case. So maybe I'm a little bit wrong on this one, or my earlier assessment. Yeah. It seems like it would be tricky to do the keeping one because of these zeros and stuff like that. Let's see. So how do we remove k digits, right? So I think we could do it in a greedy way, actually. So what we can do is process from right to left to keep track of the numbers to the right. But then here we go, for example, 4. Is 4, okay, well, let's go start with 1, obviously, right? Okay, let me put it here so that we can see a little bit better. I think I now have an idea, which is that, okay, you start with 1, and then you ask, is there a smaller digit to the right to kind of keep it? And if there is there one that would give us enough digits, right? What I mean by that is that if you want to remove k digits, And for example, let's say you have 1, 5, I don't know how to do it. Let's see what's an example in my mind. But let's just say you have something like, okay, yeah. So you have something like 5 and then 1, right? So in theory, you'll be like, oh, 2, but then you could go to this one in the right. But let's say k is equal to just 1, right? If you skip all the way from this 2 to this 1, then you already used up all your quota of k's. So that's not possible. So then now you know that you have to keep the 2. Do the same with 3, 4, and then when you set to 5, you say, okay, we only have to keep k is equal to 1, so then we can delete it, right? So that's an idea. It's not quite complete yet, I don't think, because the idea is, because I think there is a trick in it, or it's not that tricky, but it's just about thinking through the cases, is that, so you have a similar thing where it's something like this, but you ask yourself, okay, let's say you have maybe a similar thing, right? Okay, let's just use the same thing, but now you have 2 numbers, right? And then the question is, let's say you have k is equal to maybe 2. Then the question here is, okay, for example, the 5, do we go to the 1? Or do we, okay, let's go start from the left, right? Let's say the 2, if we go to the 1, then we skip 4 numbers, so that's no bueno. Let's say we have the 3, then we go to the 1, then we skip 3 numbers, right? And then the 4, we skip 2 numbers to go to the 1. I guess that's good. Actually, maybe a different one is something like this, right? Maybe that's slightly different. I'm just thinking about the cases allow as well. So yeah. So for example, at the 4, you could remove the 4 and the 5 to get the 2. Or does it make sense to remove the 5 and the 2 to get the 1, right? In this case, it actually is okay to get the 2. I guess the differentiation that I'm trying to think is whether it's okay to get the next smallest or the actual. I think you just keep going to see. Because then I think the idea that I'm trying to think is okay, right? Like, I don't know if I'm articulating the edge case that I'm struggling with in my mind a little bit, which is that, okay, like you can add more digits to kind of make this like fluff it out a little bit or whatever. But then the idea is like, okay, like let's say at this 4, let's remove the 5 for now. Right? Here at the 4, do you remove? Maybe it doesn't come up because maybe in the earlier stages, well, in this case it's a little bit awkward, but let's just change this to a 2 and a 3. Then in this case we force the 4, right? And then the 4, you ask, okay, is it better to remove 1 4 to have a 3, or 2 digits and have a 1, right? And I guess you have to answer that every time, and I think that's okay, because I think what you want is to remove any number as long as it's in the budget and there's no decision because of the greedy thing that we talked about. So that means that we get the lowest number, lowest next number that's within k, and it's okay to use as much as we can because, like we said about greedy, the most significant digit is going to, like the rest of the digits will be smaller, or will make the whole number smaller because you're the most significant digit, right? So I think that's basically the idea that I have. And then the other thing, of course, is that you cannot do anything n squared because n can be 10 to the 5th. So the idea that you would have here is just keep track of where all the digits are. I think that should be okay. I think that's a good start. I think this is a little bit awkward though. I have to think about how to do this, right? Because this is the only time where I mean, this is the only time where I don't know. Maybe I just have to handle 0 differently, right? Because the idea is, let me see if I can think up something right now. Because I think the thing that we have here with this removing thing, right, is that we always replace one digit with another digit, which is obviously, good for our greediness. But then this case kind of breaks it up, right, with the leading zeros, because effectively for 1k cost, you can remove multiple digits, right? Or does that still hold? Let me try to think that for a second. So I'm moving the camera a little bit closer or whatever. Because maybe that still holds, right? Because for if one goes to zero, like when we look at one and then we look to the right and it goes to zero. Yeah, I mean, I think that then we can go to it and we place it and then we just kind of chop it off or whatever. Excuse me. Okay, let's see. I mean, I think this is where. I'll hit my elbow and something. I think this is where sometimes we. Let's just run it out and see what it feels like. And and this is where I always am a advocate of TDD to an extent, at least especially for Leetcode EPROMs because they're very self-contained, right? So it's very easy to kind of think about it. So here, let's at least solve the other cases, and then we can talk about. This is very awkward, but yeah, and then we can talk about yeah, and then we can think about the edge cases. This is, I mean, I guess this is a medium, but it's still kind of very, very tricky though. But anyway, okay. So n is equal to length of nums, and then okay, if n is equal to k, we just return 0. I don't know if this is necessary, but I just feel like, okay. And then now we want to pre-process the digits. So index x in numerator num. What we want to do is I just say lookup of x. We append the index, and lookup we just have a collections.default dict of a list, right? Yeah. Yeah, okay. And then now we go again for actually we want I want this to be a key deck, maybe. How do I want to do this actually? What I mean by that is, how do I want to keep track of what to remove and what to keep, right? So okay, so here maybe we can do something like okay, let's just say remove maybe is equal to force times n. Yeah, maybe that's fine. And then now we start with the current index at 0, say, and then we do while index is less than n. What do we do? Okay, current index is this is the current number. What we want to do is, let's just say current is equal to this. Let's just say this is an int. Actually, I need to fix this because this is a string. So then now we just we count backwards, right? We go for I is in range from current -1 to 0, and then decrementing, right? So basically the idea is that we the way I don't think I explained it that well, but so the way that we have it here, the idea is that we can look up the next next index that's in here, right? So then here we greedily actually this is a little bit awkward. I think what we should do is greedily look for 0 from 0 to I think I'm used to writing it, but yeah, from 0 to current. Yeah, and exclusive of current, because if it's the same digit, you keep it anyway. I think that makes sense because you can always remove future, maybe. Is that right? Actually, I don't know. That is very awkward, isn't it? That is another case that I don't know if I considered. For example, like if you have, I don't know, let's see. If you have like 1, 2, 1, 2, 3, 2, 2, right? And if you could remove 2 digits, you had the 2, do you remove the 3? Or do you like the 2 and the 3? or you just keep going. I guess keep going is fine because in the 3 you replace it with that next number anyway. So okay, so I think we're okay here actually. Yeah. Okay. So then here we go. Okay, if do lookup of current. So first we check that this is. We check that this is greater than 0, and lookup of current of the first index. If this, so this is the index that is what the next digit of it. So then that's minus index. So what this is saying is that we're replacing this with that. So if this is greater than, or sorry, if this is less than or equal to k, then we do, let's see, so this cannot be 0, so this is always going to be at least 1, and if this is 1, then we move 1 digit. So okay, I think this is, yeah, I think this is right, and we can use equal to. That's what I was trying to think. Then we subtract this delta, and we move. We set index is equal to lookup of current of 0, and this is where that comes from. But yeah, and that's it, I guess. What I actually forgot, or not forget, but I didn't do, is that while lookup of current is greater than 0, and lookup, well, I have to fix the typo first. Lookup of current of 0 is less than current, then we pop, right? We pop left. So basically it's just getting rid of the old ones. And and the reason why I don't worry about the complexity is that for each number in the input, that each digit, we only pop once, right? So this is going to be linear, even though it looks really awkward right now in general. Yeah, and this is okay. And then at the very end, we have to figure out how, like, okay, so now we skip to it. Okay, what we want to do here is break, actually. Okay. I'm trying to think. So what I'm thinking right now is how to move the index if all these fail. I guess I could do this. And that should be fine. Note that we didn't use the remove yet, so it's a little bit awkward, but that's fine. Here we can do some a quick for loop of for x. Yeah, okay, for x in range from the current to lookup of nope, this is, I think I mixed up somewhere. That's my, oh man, because I have this for I, and then I keep on using current. So actually all this is wrong, and I only notice this now. My four friends, from, okay, so from current to this thing, I should probably cache it, so because I keep on calling it, and it's not free, but it's probably fine. And then now we go remove of x is equal to true, and that should be good, right? And then now we can do something. Let's just print this real quick. Just trying to see whether this make sure that I didn't have any infinite loop situations. Collections. Oh, this one. Whoops. That's what I'm trying to fix. Okay, so here we don't remove anything, which is obviously pretty bad. But that's weird, actually. So things go pursue. This is okay. This index is right. Okay. This is, you gotta. This is. Okay, so what I'm struggling with is that I keep missing current and index. This should be index, so this pops, This is good. The current is the number of digit. So that's not right. We have to go from the index to there, which is actually the same as here. So this one's right. And here, this is lookup of I, not lookup of current. A lot of silly mistakes on this one, not gonna lie. Okay, so this looks a little bit. It definitely looks a little bit better, but still wrong because this is now saying. Oh no. This is the remove. I forgot. I forgot if I was doing remove or keep, but then now you can do something like return to do that join. Maybe something like zip of remove and nums. Let's see, for r and or x in this, if not r, so if it's not removed, then we keep the x. Yeah, okay. Oh, but I'd have to remove the leading zeros, but that's okay. Yeah, so I have to remove the leading zeros. I'm surprised this worked. Oh no, that's because I have this, but I could also do. I have to do another test case of just leading zeros of. Okay, so of one. Is that the only one, or this and also two maybe? But we're mostly there actually, so we should be pretty good. I think all we have to do left now is just remove the leading zeros. So I think there's a left strip of. I think that's right. Oh, but this now gives me the wrong answer for zero itself, as you can see. This is annoying. Okay, fine. Okay, so this just basically checks for leadings, checks to see if there's no digits, then it's zero. Ooh, what did I click on? An ad, I guess. Am I good? This is kind of yucky, to be honest. I'm okay with kind of submitting a YOLO label. Let's give it a submit. Apparently I did it last time in the first try, so oh no. Huh, how did I miss this? Oh, I forgot this one case is true. So I'm already didn't bring it last time. I forgot that we have to force to do K or force to remove K. Because here, the one thing, so yeah, this is, I don't know if this is the only case that will come up. There'll be other cases, but what I have forgotten is that this only removes digits if it tries to get to the next digit that is smaller. But here, then we possibly have K left over. If we have K left over, then in that case, I'm trying to think. So one thing I'm trying to think is whether it is possible to have. Okay, I'm trying to think whether it's still possible to have K left over in a like my thought process is that right now we only have K left over if the result is an increasing sequence. Otherwise, you could always get rid of it, right? So using that logic, which I don't know if it's true right now, that's what I'm thinking about and whether I can prove it, at least to myself, is that if that's the case, then if we have K left over, we can just remove from the end because it's an increasing sequence, right? So that's basically what I'm thinking about. I don't know if I could prove that though. And I also wonder if like past Larry is just like knows it a little bit better, because he also did it much quicker, I think, or maybe not much quicker, but slightly quicker anyway. Okay, because if it's not increasing subsequence, then you can always remove one digit in the middle from one of these things. So I think it is true that if K is left over, yeah, let's say if there is K left over, it must be an increasing subsequence, right? We can actually, I'm also, I'm curious whether I should have assert this But yeah, so then here, oops, how did that happen? Maybe we'll just use another wrong answer and we can learn about it. This is also where I would say this is the type of thing that if you practice a lot, and these are the properties that you explore when you do the practicing and you learn for next time, right? So it's not always bad that you use something like this. It's not always great, I guess, either. But in that case, it just means that you like the like what you spend on now to explore the properties of these greedy things, it'll come back to help you in the future because you'll be like, oh, I recognize that, and I know that this is true, even though maybe you don't remember how to prove it per se, right? So yeah, okay, well, let's see. Yeah, so then here, then we want to say m is equal to length of. I guess you just actually go to right. Yeah. Okay. I mean that doesn't. Okay. Maybe I messed something up. What is K? I thought I used up all the K on the other one, but it would still match, so that's a little bit awkward. Nope, it's just 0. So shouldn't it be to -0, return 0? Is that why? Maybe I mixed that up. So if K is 1, does that go to the second to last one or something? Or am I messed up? I always am really bad at these, to be honest. No, so if, okay, fine. So if K is 0, then it's actually the only case where this is wrong. Well, at least for what I was talking about. Okay, fine. Then if K is equal to 0, return answer. Otherwise, return this the substring of the first thingy. Okay, so that looks good. But is it good enough? Let's see. I want to do something like 1, 2, 3, 4, 5, 4, 4, 4, 4, 4. And then in this case, we want to remove, say, 6, right? So in theory, it should be 1, 2, 3, 4. We'll see if that actually happens. Okay. Yeah. I also want to see. So the answer is that you should have. Well, this 5 will return it with 4. So yeah. So this should be. Let me print this K for a second. Just want to see because it should have like a 4 or 5 as a K. Just to make sure. Yep, a 5. Okay. Okay, so maybe I am a little bit more confident after running the code in my head, if you will, and then actually running the code. And let's give it a submit again, and hopefully I don't yeet another one. Oh no! Oh. Okay, fine. I am sad. Not gonna lie. So I mean, this is just me being silly at this point, right? Because this is like we returned 0, but we stripped it at somewhere. So the length was equal to what? How did I remove this though? Wouldn't this be? Oh, because I have. Okay, fine. Okay, fine. If I think I just have to write the other way. Oops. And then now I'm curious for how past Larry, did it so careful last time. Whoops. Also, let's put in a new case. How does that? I thought I have a test case that looks like this though. Maybe not, I guess. Yikes. Alright, this time I hope I'm okay. A lot of silly mistakes on this one. But after the third go, I do have a 689-day streak. I'm happy about that. Less happy is me mixing this up. But that said, this is going to be linear time and linear space. Even though this looks very complicated, there's a lot of while loops and for loops and while loops. You can think about it at that it's linear time. Well, it depends how you want to say linear. It's linear time because each digit only gets pushed once and also gets popped once. That said, because of this loop, it can be you can look up 10 digits, right? So it's going to be linear times 10 because every time, in the worst case, you can say that, for example, if the thing is like 99998 or something like 987 or 99998 dot dot dot, this would go for 10 per digit, which is linear times alpha, if you will, which is n times alpha, where alpha is the size of the alphabet, right? Here, this is just linear, and I hope you understand why for linear and space. But yeah, now let's take a quick look to see what past Larry did. Past Larry used a stack, huh? I guess that's the same idea. Man, past Larry maybe is smarter. But it's just basically keeping track of the digit. Yeah, past Larry is smarter on this one for sure. And then that forever, and then when you get the digit later that is bigger or smaller than the digit previous, then basically this is only looking at one digit previous to that, and then just keep on popping it while you can. That's basically the idea. That is actually much smarter. Wow, past Larry. Well done, well done. Current Larry, not so much. But that said, past Larry was not in Cartagena, and current Larry is in Cartagena. So I'm maybe having a little bit more fun than past Larry. But all right, friends. Hopefully this is educational. We did it another different way than we did previously, but the same idea though, which is greedy on the most significant digits. So, and I know that a lot of you struggle with greedy problems, and maybe that is just me speaking to myself. That's not supposed to be a brag, as you can see. Even though I knew all these things, it's very easy to miss cases and so forth, and that's why that's why you practice. Anyway. That's all I have for today. Stay good, stay healthy, to good mental health, and I'll see you soon. Bye bye.